So we'll go ahead and get started. Can you guys give me a thumbs up that you can hear me? Yep. Okay, good, awesome. I can't see you. I could until they turn the lights on. I know I'm what's between you and the end of the day, but what I'm going to do today is I'm going to talk about AI ops, and I'm going to try to put AI ops into a pragmatic sense, right? And talk to you about what AI ops really is and how it can benefit all of you. Let me start by introducing myself. My name is Paul Beavers. I joined BMC in 1998, so I've been with the company for 21 years. Most of that time I spent in the monitoring space, and then recently I took on a role where I run product management for our entire digital service and operations management business unit. So I've taken on a new role, and I'm excited about it. And the reason I'm excited about it is there's a ton of change in the market right now, and there's a ton of focus on how we take all this fantastic information that exists in IT and turn that into meaningful information. So what I want to do today is I want to talk to you about how we go from this idea of every time you look in a trade rag or every time you hear a conversation, you hear the words AI ops, and you don't know quite what it is, you have some ideas what it might be, and I want to talk to you about what AI ops is and how it can help you. So that's really what the intent of this session is, and that's why we talk about it as beyond the hype. So we're going to break it down into three parts. So initially, first I'm going to talk to you about the why we need AI ops, and what are the market drivers and what's happening in the market and what's happening in all of your IT shops that are driving the need for AI ops. Then I'm going to talk a little bit about what it is, I think very specifically, and we've actually got a pretty good definition from the Gartner market guide on what AI ops is and what it's all about. And then I'll talk to you about what it means to our current product set today. And when we say BMC, we say to our customers, BMC is an AI ops company, what do we mean by that? And I'll give you 5 key use cases or examples of what we mean when we say that we're an AI ops company today. And then we'll close with a couple of case studies. So what's driving AI ops today? Well, interestingly enough, and Jason talked about this today on stage, in 2016, there will be in the world 16 zettabytes of data, but that's going to grow 10x between 2016 and 2025. So the volume of information that's out there and in the market is growing by 10x in about 10 years or 9 years. And that's the amount of data that gets created each year. So if you think about 163 zettabytes of information, that's the volume of data that will be created in 2025. What you may not know, and it's an interesting trend in the industry, is 60% of that data in 2025 will be generated by enterprises and by business, where today, most of the data that gets generated is about 30% of it comes from an enterprise, and the other 10% comes from different sources. But today, about 30% comes from enterprises, the 70% comes from videos and gaming and all the different sort of consumer aspects around data. But that will change over the next 9 years, and by 2025 it will be 60% produced by enterprises. The second point that I'll make is most of you and most of your companies are digital transforming in some way. And so what does that mean from a monitoring and from an operations perspective? What it really means is your applications are becoming more and more important, right? In the past, IT and IT operations would support the business. In the future, and even today, IT is the business, right? So most businesses are digital businesses, and I always think to the story, many of you are in the banking industry, and I think to the story of, back when the banking industry first came out with a mobile app, it was a convenience feature, right? And you go, oh yeah, this bank has a mobile app. That's kind of cool. Now, at least for me, if the mobile app stopped working for the bank that I use, I would pick a different bank, right? So the performance of that mobile app is becoming more and more important. The performance of all the digital services that are provided is more and more important. So much so that there's a statistic, you can't see it on this slide, but there's a statistic that says that most enterprises are saying that pretty much 98% of enterprises are saying that an hour of downtime will cost them $100,000. So if you think about it, or more, and historically that number was a lot less. And so the importance of the applications that you're monitoring and the importance that they stay healthy is just increasing, right? So that's the major point. The last is, as companies are moving to the cloud, by 2025, $225 billion of cloud investment will be unprotected because only about, this will surprise you, only about 15% of enterprises have an actual monitoring and AIOps strategy for what they're putting in the cloud. In other words, there's a mad dash to put applications and data in the cloud, but today, enterprises don't have a cohesive strategy to monitor, manage, and understand the performance of those applications that are moving to the cloud. Include security in that same bucket. So because of that, the risk of everything going to the cloud is increased. And so when you start thinking about AIOps and how do I not be one of those companies? How do I handle the high cost of downtime? And how do I handle the volume, variety, and velocity of data? The answer is AIOps, and that's what AIOps is driving toward. If you think about it, So the challenges that you guys have as customers, because of the items on the first 3 slides, are really data overload, right? So if you think about, I was speaking with friends from one of our customers a few today, and they ingest about 1.5 billion records today into our capacity solution. If you think about the number of events and tickets that are being created with all the data that we're talking about, it's literally hundreds of thousands of events. In the older days of event management, you could go and you could write a series of event rules that would process those events and eliminate the noise, and you could actually reduce and manage events quite easily. The challenge is with the volume of events that are out there, there's too many to do that with. And what you need to do is, what we need to provide as an industry and what you need to do as a customer is you need to have the ability to break those events down using analytical techniques, machine learning, and different techniques to be able to filter out the noise, reduce the noise, and make sure that the events that you're looking at are actionable events and the events that you actually need to go and do something with. Other big challenges right now today, and you'll see there's a graphic of an AIOps solution a little bit further down, but in the market today, most enterprises have 11 or more, on average, 11 or more monitoring tools, right? So not only do you have a lot of noise, that noise is coming from a lot of different tools. And so from an AIOps perspective, you need to bring that data together, the events and the metric data together, to be able to act on it and be able to understand performance, right? So I already talked about event noise drowning out the real problems, right? So the problem is when you're dealing with hundreds of thousands of events or tickets, which ones do you care about? And by the way, if you don't pay attention to the right one, you still have an outage, right? So the noise is really creating a lot of problems and a lot of pain. And because of that, issues go undetected and undiagnosed. And then the result of that is your applications either aren't performing or you're not meeting SLAs and you're not able to to operate at the level of performance that you need to. So from an industry perspective, there's key things that have happened from a technology perspective that have enabled us to address a lot of these use cases, and we'll talk about that as we talk about more and more of this AIOps capability. So what's driving AIOps adoption? I talked a little bit about this. When you think about data, you always think about the 3 V's. If you've ever read articles and material on big data, there's volume, variety, and velocity of data. And all of those are increasing at the levels that I spoke about earlier. So AIOps is really a way to say, from an IT operations perspective, and that's a key point, right? We're not talking about a generic analytics set of use cases. We're talking about, from an IT operations perspective, understanding data that's coming at us with increased volume, increased velocity, and increased variety in order to be able to do a few things. One is reduce the noise, right? And make sure that we eliminate the noisy tickets. You will actually, there are vendors in this space that will claim, their claim to fame is we reduce the noise. We're one of them, although there's others, although I think we do it in a different way, and I'll talk about that as we go through it. Understanding root cause, right? So if you think about the number of times when there's a problem And really what you want to do is solve that problem quicker and reduce mean time to repair, right? So understanding root cause quickly, that's one of the key things that AIOps will deliver. Additionally, really understanding when things become abnormal. So you'll hear the word anomaly detection a lot. And what we mean by anomaly detection is I've got a business that's operating at a certain way, and all of a sudden something changed. A configuration change, and it caused my performance to change. Maybe it changed the pattern of events that flowed through my system. Maybe it changed the way that a certain performance metric is tracking. But really understanding anomalies and that something's changed. And it doesn't say it on the slide, but understanding that something's changed so that you can react to that change before it affects an end user's application, right? So the idea is to really be able to understand performance before it impacts an end user. And then be able to predict the future, right? So if you start thinking about what happens when you start to detect anomalies, then you have the data and the information to be able to say, you know what, I believe that if you don't do something, you're going to have an outage within a week, within a day, within 3 hours, right? So this whole idea of alerting you, predictive alerting we call it, but alerting you before there's actually an outage and saying, based on what we can tell from an analytical and a machine learning algorithm perspective, this is where you're going to have an outage and something's going to happen in the near term and in the future. The last bullet on that slide, and I didn't mention before I hit the button, is really the ability to, what you're also seeing from the definition of AIOps is not just to identify a problem and predict a problem, it's the ability to actually initiate an action. So when you look at BMC's portfolio and other definitions of AIOps, basically what you'll see is that it's about predicting that there's a problem and then running orchestration of some form to be able to address and prevent that problem altogether. What I'm going to talk to you now about is a little bit what is AIOps, and this is a little bit of an eye chart, so I'm going to dive into this just in a little bit of depth because I want everybody to understand when the industry says AIOps. So when you walk out of here and somebody says, "Hey, you heard about AIOps," there's a few things that I want you to take away from that. One is the ability to ingest data in a generic form as well as in a controlled static form, right? So when we talk about ingesting data into an AIOps platform, we're really talking about 4 types of data, right? So the first type of data is entity data, right? So the ability to understand what my servers are, what my applications are, and that exist in my environment. The second type of data that we're talking about is relationship data. So you've heard a lot about our discovery solution, and when you ingest data into our platform from our discovery solution, you're ingesting relationship data, right? We're talking about what talks to what and how things interact with each other. And of course, from discovery, you're ingesting entity data. The second type of data is event data. And event data is really, it's not event like an IT operations event. In the AIOps space or in the analytics space, event data can be thought of as any line of data that has a timestamp and can be broken into a set of common fields, right? And so when you think about an event from an analytics perspective, it's not just, hey, I recognize that I had a threshold that was violated. An event could also be a tweet, right? A tweet is an event, right? It's got those characteristics. It can be analyzed and it can be timed. It can be tied back to a given timestamp, right? Other types of events are tickets, right? So tickets can be thought of as events. Other things would be traditional IT events, log entries, right? So the ability to ingest data from log files. Most log files you can tie back to a timestamp and break that data into a set of fields. So that's the third type of data. And the fourth type of data is time series data or metric data, right? So the ability to tie something back to an entity and then understand a numeric value and a timestamp that's associated with it and be able to run algorithms against it. So that's when we talk about an AIOps platform, we talk about ingesting data in typically those 4 forms. There's other types of data like document data that fall into other parts, but typically if you're thinking about getting the value out of an AIOps platform that I've been describing, then it's that 4 types of data. The idea would be, and there's a key word on here, big data. So part of why we're so excited about AI ops as a company and as an industry is because the technology surrounding big data is supporting the use cases much better than it used to, right? So historically, we would put this data in a relational database, a very static database, couldn't handle the variety of data very well because you had fixed schemas, and now through things like Elasticsearch, Cassandra, Hadoop, these modern big data techniques, we're actually able to apply big data, or store that data in big data, which means we can ingest a lot more data. So when we were talking about the volume of data that we were talking about earlier, the ability to store that and manage that data. And then if you think about, okay, and then you see machine learning, right? And machine learning is really, it's an overloaded term, right? If you look at the Gartner hype curve, there's this, you can see where machine learning is just about to drop into the trough of disillusionment. So if you look at, any of you who look at the Gartner technology hype curve, and you look at how all the different technology trends are plotted, we're coming right off of the hype and we're about to drop into the trough of disillusionment. And what will be on the other side is machine learning that gets applied to use cases, right? So when you look at BMC and you look at our solutions, we can point, and I will when we go through it, we can point through various types of algorithms, but every one of them that we're calling a machine learning algorithm, you can map back to a use case, right? So the idea is to have, in an AI ops platform, it really is targeted at an IT operations group, is to have very specific use cases that are driven by machine learning. And then on the outside of this, you get 4 key use cases, right? So one is the ability to understand the data that you have and report on it and visualize it. 2 is anomaly detection, which I talked a little bit about, analyzing performance, and then correlating things and putting them into context, right? So understanding when a service or when a server or a piece of equipment or a piece of infrastructure or a cloud service goes down, what applications does it impact? That's contextualization. And then at the very bottom, you see ACT, right? So when you think about what is an AI ops platform, this is Gartner's definition. By the way, it's not a BMC slide. If you go get the Gartner market guide, it came out late 2018. This is Gartner's definition of an AI ops platform. And I have to tell you, we were lucky because we were able to, 1, contribute to this and also be a part of the market guide, but 2, it's a strong validation of what we're thinking from an AI ops perspective, both where we are today, which I'll talk about, and then also where we're going. So if you think about AI ops, you can think about it through a couple of key phases, 4 key phases of AI ops. And again, this comes from the market guide. There's what they call descriptive IT. And what descriptive IT is, it's just like what it sounds like. It's the ability to ingest data, understand it, visualize it, right? So there's many, many vendors out there that report, and they would call themselves an AI ops vendor. I would call them a partial AI ops vendor because they are filling part of the AI ops workflow with descriptive IT, right? So this is really the ability to ingest data and present it back. And so there's quite a few use cases that get driven from that. Simple dashboarding. A lot of times, even if you walk through a network operations center, you'll see a TrueSight or other vendors' dashboard showing that. Did I do that? That's pretty cool. Showing the applications, or they're basically showing applications on a dashboard that are actually presenting status. That is descriptive IT. But it is considered as a part of the overall AI ops flow. The second one is, we talked a little bit about this, is anomaly detection, abnormality detection, understanding when things become abnormal. That's typically machine learning based, right? And the very earliest, and we'll talk about it a little bit further down, but the very earliest machine learning algorithms were dynamic baselines, really, which was really taking and understanding how a metric's performing and then understanding when that metric becomes abnormal. So this anomaly detection also is where you start to get into correlating things that happen over time and how they relate to each other. Then the market guide talks a lot about this, but then you move into proactive operations, right? So this is the ability to do things like predictive alerting, right? So when I said earlier, I talked about estimated time to failure, and what does that mean? And having the ability to say, you know what, if you don't do something about this metric in the next 24 hours, you will have an outage, and being able to predict outages and understand what's going to happen in the future. We, BMC, also tie this ability to do intelligent ticketing into that, right? So the ability to say, from the perspective of having an outage, let me create a ticket in your ticketing system that gives you context and a lot of other information from your AIOps platform into your ticketing system so that you can solve that problem faster and reduce mean time to repair. But most importantly is the last category. And the last category is avoiding high impact outages, right? So improving MTTR is great. Improving mean time between failures, or decreasing the total number of failures and the total amount of downtime that you have, is even better, right? So that ultimately, that's where we're going from an AIOps perspective, is understanding performance, being able to understand what's going to happen and be able to get in front of that and not have an outage, right? And so, and I would take this whole thing one step further. I was talking about this in one of the breakouts, one step further to say that really what you want your AIOps platform to do is you want to understand a problem or an outage before a human being recognizes a problem, right? So you can think about all this monitoring and everything that we put in place is for that purpose, right? Or before a human being does, or before there's a business impact, right? So I talk with a lot of our customers, and one of my favorite customer stories is they actually there's a customer that implemented True Site Operations Management, and they actually have an SLA that says that 70% of any issue has to be found by the monitoring and not by a person, right? So if there's 100 issues and 31 of them are found by people and 69 are found by the monitoring, then they actually don't get their bonus. So 70% of the time, the monitoring system has to find and fix a problem. Pretty much find. They're wanting to get to automated fixing, because at the end of the day, where you really want all this to go is you want to go from just detecting problems to detect a problem and then fix that problem and then register the right tickets without human intervention. So on the stage earlier today, Nayaki, at the very end of her presentation, she talked about autonomous IT. That's our goal, our collective goal, right? Get to the point that when we recognize a problem, or we recognize that we're going to need more capacity, or we recognize that there's a security threat, we can either resolve that problem, remediate the threat, or provision the capacity that we need without human intervention, right? So where we are today, and what I like about that journey is, if you think about self-driving cars and that analysis, today, most of us don't have a self-driving car, and most of us don't trust a self-driving car. But what we are getting more and more of is an augmented experience. Just the other day, my family member, my dad, bought a new car, and he said this car has a feature in it, which is a cruise control, and basically this cruise control will not let you hit the car in front of you. So I got in this car, I didn't believe it. And so I was driving down the road, and I literally put the cruise control on, and the guy in front of me, I followed him up to a traffic stop, and his car stopped, and then my car stopped right behind him at a very safe distance. We call that augmentation, right? So it's not a self-driving car, but the reality is that feature will do a lot to keep my family safe. And so if you start thinking about what we can do from an IT perspective, while we might not be at that end goal of completely autonomous IT, we will be able to do more and more in terms of augmented experience and automating more and more. And over time, we will realize the vision that Nayaki described on the stage. So I talked a lot of what was on here, but a lot of what our customers are doing in order to improve the overarching experience and leverage our AIOps platform, think of it in four areas. One, consolidate monitoring, right? So you've probably heard us talk a lot about True Site Operations Management as a manager of managers. I don't like that term. I prefer AIOps platform, because we're not just managing the managers that are out there. What we're actually doing is bringing data into our platform from a variety of different platforms, and able to perform analysis on that data to deliver on some of the use cases that we talked about. To proactively remediate, again, I just described what that would be, right? So proactively remediate is I've got a problem. I recognize that I've got a problem. Oh, automatically reboot a server, right? I don't know if you've ever seen BMC's Network Operations Center. Scott Fulton, our CIO, who is here today, built out a Network Operations Center. We run that Network Operations Center with 2 people, and we have monitoring implemented. And when we implement that monitoring, when we detect a problem, there is an orchestration script through our TrueSight orchestration capability that fixes those problems or opens up a ticket with a lot of information so that we can fix those problems faster. So really being able to proactively remediate. Other is increase efficiency. The way we increase efficiency with TrueSight operations management and with our approach around AIOps and our capacity solution is we reduce the noise, right? So if you look at it, a number of our customers have substantially reduced event noise. As a matter of fact, in our latest version of TrueSight, we actually have a noise reduction indicator that says with the rules and the analytics that you have in place, here's a percentage of event noise that's been reduced. And we do that to help you explain to your stakeholders what the value is that you're adding. And then most importantly, similar to what you saw on the previous slide, is about avoiding downtime, right? And so that is really, I want to understand a problem and fix it before it impacts somebody. So let me talk a little bit about, so I hopefully set up why you need AIOps and what it is. What I'm going to talk to you about now is in our solution, how does our solution solve problems using AIOps? And so I'm going to talk about it in 2 different perspectives, and we'll go through it here. So first, I already talked about it, and I stole my own thunder because what you see on the screen is the event noise reduction indicator that I spoke about just now. But really, the ability to take both a deterministic and an analytical approach to reducing event noise, right? So deterministic means I have some rules, I have some event policies and event characterizations that I apply to events, and then an analytical approach would be correlation would be an analytical approach. Show me events that are related. But we have the ability to, within the TrueSight Operations Management platform, to reduce event noise. And most of the time, this is a key objective of people that are putting our event management capabilities in place. Most of our customers are able to reduce event noise from 60 to 90%. And so really understanding the right time to use deterministic rules versus when to leverage analytics, when to leverage log analytics, and apply those. We basically have built into the platform noise reduction. And what we started doing recently is calling out what that noise reduction is, and that's what you see with our noise reduction indicator. Probable cause analysis. So what probable cause analysis is basically the ability to run a machine learning algorithm that understands all of the abnormalities, anomalies, and events that are happening related to a given application or service, and tell you what the most likely technical cause of that problem is. So the use case that I think about the most is, let's say I have a big application, it has hundreds of servers supporting it, and it's got, at the very top, it's got a web interface. So you could be running a synthetic transaction using our software to monitor the performance of that web interface. Then, let's say, for example, that performance, we recognize an abnormality. So notice I didn't say a threshold violation. We recognize that performance has become abnormally slow. Hopefully before an end user has recognized that the performance has become slow, and then we'll issue an event, and then you can click on a button in our platform that says run a probable cause analysis, and the output of that are all the technical events that are correlated back to that slow performance. And so the events that are correlated could be CPU on one node of a load balancer, or it could be I have an app server who the JVM is running out of memory. And so those events are correlated, and we'll score it. You can't see the percentages are right here. We'll score it with the most likely cause of that outage. Right, so think of a Google search which tells you, back in the old days, there used to be a percentage, and it would say this is the most likely search term that would satisfy your search. So that's what probable cause analysis is about. We've recently gone from just tying it back to an event to saying, hey, if I have an application itself that is unhealthy, let me run a probable cause analysis and come back and show you what the most likely cause of that outage is. I skipped one because when I was clicking, so I'm going to go back. Yeah. I talked about this one a little bit earlier, but dynamic baselining and the ability to predict a problem before it happens. We believe, and we've had in our platform for a while, and we've done some things to enhance it a lot, but we've had in our platform for a while this idea of dynamic baselining and telling you when something becomes abnormal. So when that end user performance that I was talking about earlier becomes abnormal, then we have the ability to say, okay, give me an alert that this has become abnormal. Now that's interesting, but what's even more interesting is if you compare reacting to a performance metric that becomes abnormal when it becomes abnormal to waiting for it to violate a threshold, that's prediction, right? Let's say, for example, that end user performance metric became abnormal at this point in time, and if we were measuring with a static threshold, 3 hours later it would have violated that static threshold. That means before an end, I'm 3 hours ahead of what traditional monitoring techniques would tell me, and hopefully 3 hours ahead of when a user actually would be impacted or be dissatisfied. Okay. So then the next thing that I think makes us an AIOps platform, and I believe that it does, is the ability to run automated operations. And I mentioned this earlier when I talked about our NOC, right? So if you think about the ability to have an event happen, initiate a run book, have that run book resolve the event, update all the audit logs, all of the tickets that are associated with it, in some cases issue a change request depending on your company, and then come back to you and say, okay, I fixed the problem. That is pretty powerful. And so we have a lot of these run books that our customers implement that they're able to do one of two things. They're either able to automatically go initiate a run book and fix a problem. So that's one way that they do it in a platform. The second example that you see on the screen is you can also, if you don't want to just automatically fix a problem, you can also set up a catalog and where your operators can click on event, and then when they see that event, they actually can choose an action to run, right? So if you want to be in front of it more and you want to make it still have that human step in there, you certainly can. And so that's really when we think about automated operations, that's what we're talking about. But the whole TrueSight platform is back-ended by a part of the solution known as TrueSight Orchestration, which is an industry-leading runbook automation platform. What we've done is integrated it into this platform to really round out us as an AIOps platform. Yeah. Automated service resolution, which sounds pretty similar to automated remediation. The difference is automated service resolution is all about creating a ticket in our incident management solution. So there's an integration with our CMDB, Discovery, and our incident management solution that says, hey, when we detect a problem, I can tell you not only that there's an alert, I can tell you the application that's affected, the CI that's affected, and really create a closed loop process where I'm talking to, not only am I talking about in my ticketing system, hey, here's just an event that happened. It's an event that happened in the context of this business service or application, right? So the ability to integrate across our portfolio to create automated incidents, but automated, we actually have, sometimes we call this intelligent ticketing. So automated intelligent incidents, because that incident carries with it in its payload an understanding of the applications that are affected and the services that are affected, as well as the devices that are around that service. And last but not least, there's one other key element. It's much more worthy than of one slide, but really, when we think about AIOps, you think about machine learning algorithms. We have built into the TrueSight platform, or as a part of the TrueSight platform, we have an industry-leading capacity management solution that allows you to apply machine learning on performance data and predict future utilization, predict future outages, estimate time to when your applications become saturated, really understand capacity and performance, both in the context of infrastructure as well as in the context of a service. Associated to that, we also have the ability to make those same kind of predictions from a cost perspective when you're in the cloud. Because in the cloud, you don't ever run out of capacity, right? It's infinite or virtually infinite capacity. What you run out of is money, right? So I can sit here and provision stuff all day long in the cloud, and as I do that, I create more and more costs. Well, I need to alert you, and I need to warn you, and I need to help you manage a budget. So we leverage machine learning algorithms as part of our AIOps platform to be able to manage costs, future utilization, and capacity, right? And be able to understand waste. But again, the reason we put it in as a part of this conversation is because if you look at what makes up an AIOps platform, that's what makes up an AIOps platform. It's the machine learning and AI algorithms that fit behind all the capabilities. So a couple of case studies. So we've implemented this AIOps end-to-end solution in a number of our customers. This one is USDA. So Scott O'Hare at the USDA reached out to us, and he's implemented this solution, and he's ingesting data from a variety of applications. The most important metric on this slide is he reduced ticket noise by 75%. That basically means that prior to implementing this solution, only 25% of his tickets were actionable. Right, so he was able to only now report actionable tickets, reduce the noise, which basically makes him look better as a service provider, and two, it saves a lot of time and makes him much more efficient. The other two metrics on this slide are all about being able to do more with less, right? So able to bring 7,000 monitors under environment, both from a public cloud, private cloud, and on-premises resources into a monitoring environment. And each year he grows by about 25%, and he doesn't add headcount to do it. So again, if you start thinking about a pragmatic definition of what AIOps is, and this is really what it's all about. It's about implementing the solution, leveraging the machine learning and algorithms that are a part of the solution, and being able to solve some of these real pain points. The next case study, and this is an interesting one of my favorite, is actually Park Place. So are the guys from Park Place Technologies out here? Where are they? There they are, yep. So they could probably tell you this story much better than I can. But at Park Place Technologies, they've created a managed service to sell to their customers for monitoring, right? And so Park Place was a third-party maintenance company. They basically provide warranty and maintenance work on hardware for companies after the warranty period. What they've done is it's really fantastic. They've used TrueSight to implement an AIOps platform and offer to their customers, hey, you don't just have to call us when something breaks. You can actually call us, or we'll call you when something breaks, and we'll show up and we'll fix it, right? So this story with BMC and Park Place as a partnership is a fantastic one. They've got, this slide says 500. That was back in June when we built this case study. I think they're up to about 900 now in the actual. Oh, I'm getting a thumbs up, so even higher. So more than 900. So they basically have rebranded TrueSight as ParkView and are leveraging it to ingest hardware data and hardware monitoring. Basically, what it's also allowed them to do is increase their first-time fix rate from 86% to 99%, right? So a big goal at Park Place is fix it right the first time, or I don't want to have to revisit because a truck roll is expensive, right? And so being able to improve their first-time fix rate to 99% is really pretty amazing. So it's a great story, and they're leveraging it and they're really pushing value through the TrueSight system. So this slide's a summary slide. So let me just summarize by saying, when you think about AIOps, you think about it as descriptive IT, you think about it as anomaly detection, you think about it as proactive operations, and then more importantly, avoiding outages. Really, when you put together an AIOps platform, that's really what you think about. And what I like about the bottom of this chart is it really shares for you exactly how we at BMC believe we solve these problems. This isn't a roadmap discussion, but what I will tell you is there's an entire roadmap beyond this that starts to get into ingesting more and more types of data and applying more and more algorithms to it. So with that, I'll go ahead and wrap up here. Thank you very much for your time today. I appreciate it.